Okay, my goal here today is to switch over an RV incandescent light fixture to all LED, and to start I'm going to show what complete fixture looks like. This is a duplex fixture and we're going to be using a single fixture, but I want to show you this one just to show you what you have to do to start. Take the bulb out, and all of this has to go here. This reflector, this just gets in the way of the bayonet fixture. On the back there's a white wire and a black wire. Just clip those right off, and then whatever you have to do to get the bayonet fixture out and the reflector out, probably a Dremel grinder, which is what I've been using right in here, gets that right out. Okay, that's that one. So we've got fixture here, single fixture, and I've done the grinding on the back, taken this particular reflector out. That's good, that's gone. That leaves a hole right here which we're going to use, and all of this reflector area here is what we're going to put our LEDs onto, so we're free of the incandescent. Now what we're going to be using is LED on a strip like this. This is 120 LEDs per meter. It's from Lee Valley Tools. Pressure sensitive back. It's 12 volt DC, and we're going to put 4 by 4 inch strips onto the white reflector and wire it up. Okay. Just to finish off on this, the magic of this particular material is it can be cut. It's marked at every inch, and there's 4 little copper buttons right here. Wires can be soldered directly to those, and that's what we're going to do. Okay, on the single fixture, show you the back side of it. Here's the wire pigtail, and this is the power lead. This is the one that joins right up to the wiring in the RV. This black wire, which I clipped off, and which I'm hoping you're going to do, is the one that goes to the back of the bayonet fixture. The white wire is totally gone. Okay, put that there. On these LED strips, it is marked for positive and negative. And we must keep the positives positive, that's your power, and the negative is the chassis ground, or the neutral wire, and that will wire into the switch. The black wire that I'm going to be using will go into the black or into the positive button. We're going to solder right on these. I'll show you how to do that. Okay, for purposes of demonstration, I've got a small scrap piece of LED about 1 inch long, and I've got the positive terminal towards me and the negative terminal towards the camera. Just going to tape this down just so that it doesn't want to move anywhere. And the solder that I like to use for projects like this is Solder It. It's got solder and flux paste together. So squeeze out a little bit on a card like I've done here. Take a tiny amount on a toothpick, just put it right onto the copper button, like that. I'm also going to tin the end of my soldering iron, and it's got a very fine tip, and what I want to do is just put this solder onto the copper button. It's made a nice little copper, the solder is actually pulled up and made a little button itself right on the copper. Now the next thing I want to do is use a very fine wire, and I've got some here. This is from an old IKEA kit. It's fine stranded wire, and I'm going to clip about a 4 inch segment off that. That. Going to bare the end, twist that together, and get a little bit of solder on the end of the wire. Use the iron to heat that up. There. So I've actually tinned the wire itself. Now going back to the strip, I'm going to put this soldering tip right onto the solder that I have there and push the wire into it when it's molten, like that. There we go. So that's our first wire soldered to the copper button. Now this is positive, and the positive is going to be a black wire. Since all I've got is all white wire, to keep these straight in what we're doing, is I'm going to mark this as black, and I know that that's the positive connection I have to make through the switch. Okay, now the balance of this is to solder another wire on. You're going to be doing this with a 4-inch strip. And what I found very useful to do is to put the strip in place already on the backing, 1, 2, 3, 4, and then solder so that the little strips can't go anywhere, that they're nice and secure. Okay. Next thing I'm going to do is to cut 4 4-inch strips, and I'm going to put them onto the reflector, one strip here, 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 and here. And then I'm going to solder the wires just like I showed you in the demo. Mark all the blacks and leave the whites white. And then the wires themselves are going to get pulled through the remaining hole here and wired up to the switch on the back. So let me put the strips on and I'll be back. Okay, LED strips are in place, and I've got all the wires here. Don't be daunted by this, it's simple. There's 4 blacks, 1, 2, 3, 4. Black goes to positive. First thing we're going to do is pull the whites to the back and leave the blacks on this side. So we'll thread the whites through, like that, like that. Just keep going till the whites are all on the other side. When the whites are through, pull them together, clip them all to the same length, like that. Use a wire stripper to bare the ends. Did about a 1/2 inch, and we'll do the balance. Okay, the whites are all pulled through, they're clipped to the same length, and they're all bared at about a 1/2 inch. Just going to twist all these together. I'm going to solder on a piece of 18 gauge automotive wire, and that'll be our white, neutral, or negative pigtail for installation in the RV. Okay, I've soldered the white wire on, and I've just used regular electronic solder for that, and soldered that on with a bigger iron. And what we're going to do to finish that particular joint, tug on it, it's nice. The solder connection is nice and silver bright. I'm going to put a little bit of shrink tube on, and that'll be the insulation that covers the joint. Get that on. I'm going to use a little butane torch to shrink the tube. Okay, that's our white lead, and that's the neutral or negative wire for connection into the RV wiring. Okay, I'm going to proceed to pull the blacks through, and then the blacks are going to get joined onto this remaining bit here, which was cut off the bayonet fixture. So all the positives will go to this black, and positives are still on this side marked. I'm going to pull those through, bare those, solder them exactly the same way. Okay, I've soldered all the blacks to the remaining short piece of the black wire coming out of the switch. And when you do this, remember to put your shrink tube on before you connect, because you're in a loop right here and you can't get it on afterwards, of course. So put your shrink tube on first, out of the way, and then we'll pull the tube in place and then shrink it down. And we'll be back. Okay, that's pulled into place. Shrink that tubing. That's done. Okay. We have our black pigtail for connection to the positive side of the electrical in the RV, and the white for connection to the negative. So we've got our two leads. The switch is going to be worked just as before. It will make and break the power. Power comes in, connection is made or broken here, and then your power goes to the LEDs, and then the white supplies the negative to the balance of the LEDs. So we're done on this side. There's the fixture complete. Now I'm just going to set up and we'll do a little test with a bit of power on it. Okay, I've hooked up to a 12 volt DC power supply, and let's try and see how we did. Okay, it looks good. Now this fixture is as bright as, or a little brighter than the incandescent bulb that it replaced. And the reason that you're probably researching this or wanting to look for LED replacements is that I can use 8 of these fixtures for one regular incandescent bulb. So one regular incandescent bulb burns 8 times the power as this. If you're dry camping running on batteries, this is important. If you use the lights at night inside, you can deplete the power quite a bit. And we camp in the mountains, and you don't want to have a shortage of power during the night if in fact you need your furnace. So the LEDs will preserve your batteries much longer, and hopefully give you much more enjoyment. You can have a lot more light on in the RV than you could with incandescent bulbs in the past. Now, Lee Valley Tools, where you can purchase a strip, is all over Canada. And for those of you that do woodwork, you'll know Lee Valley. And for those of you in the United States, Lee Valley Tools has opened up there a number of years ago. You'll be able to find them online. The particular brand of the LEDs is Armacost Lighting, A-R-M-A-C-O-S-T Lighting. You may search for that online and see if you can find LEDs anyway. Hope you found this video useful, and I really hope a lot of you will try switching over. I have found the cost of LED bulbs, if you want to call them that, a direct replacement for the incandescent bulb, to be just horrendously expensive, $35 or $40 for 2. That may have changed in the last while, and that would be good, but this is a good inexpensive way to go. The switch over here cost me about $10. Now these are 12 volt DC LEDs, and an RV will put out 12.6 volts on full charge. That does not harm the LEDs at all. They just run a little warmer, but their life is measured in tens of thousands of hours. So I don't think you're harming the lifespan at all for using them this way. Okay, that's going to be the conclusion of this particular project. I've done this for a number of years and just about switched all of my RV over. This one will get installed in the spring and ready to go for camping. Happy camping!